Hi, I'm Andy and this is question 3 on the AQA Mechanics 1 paper from June 2012. For more questions on this exam paper, click the eye in the top right corner. In question 3, a car is travelling at a speed of 20 meters per second along a straight horizontal road. The driver applies the brakes and a constant braking force acts on the car until it comes to rest. In part A, we need to assume that no other horizontal forces act on the car. And in part 1, after the car has travelled 25 metres, its speed is reduced to 10 metres per second. We need to find the acceleration of the car. So we'll start by writing down our values for SUVAT. Firstly, we know the initial speed is 20 metres per second, and we know that after 75 metres it's reduced to 10 metres per second. We're trying to find the acceleration and we don't know how long it takes. So we want an equation involving S, U, V and A. The equation we want is V squared equals U squared plus 2AS. So 10 squared will equal 20 squared plus 2 times A times 75. So if we rearrange this to get A on its own, we'll need to subtract 20 squared. And then we'd need to divide through by 2 times 75. And that gives us A is minus 2, which makes sense for it to be negative because it's decelerating. In part 2, it says find the time taken for the speed of the car to reduce from 20 meters per second to 0. Now, because in the first SUVAT equations we went between 20 meters per second and 10 meters per second, we need to do new SUVAT equations because the new final velocity will be 0 meters per second. So this time we don't know the displacement. The initial velocity is still 20 meters per second, but the final velocity this time is 0 meters per second because it comes to rest. The acceleration is minus 2 because it's constant acceleration, so that's the same for all parts of the journey. And we don't know the time, that's what we're trying to find. So to find t, we can use v equals u plus at. So 0 equals 20 minus 2t, which means 2t is 20, and t must be 10 seconds. In part 3, it says given that the mass of the car is 1,400 kilograms, find the magnitude of the constant braking force. So if we assume that the direction of motion is to the right, that means that the braking force must be acting to the left. The mass is 1,400 kilograms. And as there's only one force going to the left, that means that the acceleration must also be going to the left. And we know the acceleration is 2 meters per second squared. So setting up an equation using Newton's second law, we can say that the force, the only force involved here, is mass times acceleration, which would be 2,800 newtons. In part B, it says given that a constant air resistance force of magnitude 200 newtons acts on the car during the motion, find the magnitude of the constant braking force. So for part B, we've got a similar situation to what we had previously. We've still got a braking force, we've still got a deceleration of 2 meters per second, but we've got an additional force of 200 newtons, which is in the same direction as the braking force. So if we set up an equation using Newton's second law, we would take left to be the positive direction. We get F plus 200 newtons is going to equal mass times acceleration. And so if we calculate this, we get 2,800, and then we need to subtract the 200. That's going to give us 2,600 newtons.